This video we're going to continue talking about standing waves. The last thing I was talking about was an analogy with swings, and I think it's a good one. So again, if you're at a playground and you're on a swing and you're being pushed, there are a few good ways to push someone. And the best time to push someone is when they're kind of at their peak. You can see they swing forward, and when they swing back, once they're at their peak of where they've swung back, they'll actually stop in midair. And they'll be still for a split second. And that's the best time to push them. And if you keep doing that, they'll swing higher and higher and higher and higher. And you'll see that by pushing at the right frequency, by adding energy in at the right frequency, that energy will accumulate over time. And there are a few different frequencies that it'll work for, but in general, if you are pushing every time they get to that kind of high point, that would be the fastest way to make them swing really high. But if you did every other one or every third one, you would still be adding energy to them. Now, if you push them while they were still coming towards you, right, so they would be coming towards you and you push against them, you would be slowing them down. And the person in the swing would kind of rock around a little bit, but they'd slow down. And so when you don't push at the exact right time, you tend to kind of cancel out some of the energy that's in the system. And so those specific frequencies that allow you to keep adding energy are the resonance frequencies. And the same is true when we think about a slinky. There are certain frequencies that I can disturb the slinky at that will create standing waves. And those are the specific frequencies that again, create that constructive interference between the incoming and reflected wave. And just like the swing, it allows you to keep adding energy to the slinky. And instead of having some of your energy cancel out what's already there, it tends to add up over time. And that's where I can get a really large standing wave with a really large amplitude by only moving my hand a little bit. And remember that the amplitude of a wave reflects how much energy it has. So kind of the longer I'm shaking the slinky at the resonance frequency, the larger the amplitude gets. So it's visually showing you that energy accumulates in standing waves. And that's also why standing waves have very large amplitude, right? So they kind of keep gaining energy and gaining energy and gaining energy, so the amplitude gets larger and larger. And that is what allows you to do things like this, right? Which is kind of the classic example. You can get a wine glass to shatter. And that's because the speaker is playing at a resonance frequency for the glass, which means that it will create a standing wave in the glass. And so the glass is kind of waving around. So you can have standing waves not only in one dimension, like a slinky, but in 2 and 3 dimensions. So something that's got 2 or 3 dimensions to it. And so that standing wave in the glass got larger and larger and larger in amplitude as the sound waves continued to disturb it at the right frequency. So the amplitude eventually got so large that it broke the glass. Another really cool example I like is this. So this is finding the resonance frequencies of a kind of a flat plate. You can see that once a resonance frequency is found, you'll get that, which is this very specific pattern. And there's salt on that plate. So where the salt is staying, that is a node in the standing wave. So this whole plate is vibrating 2-dimensionally. But all along this surface here, there's a node, and here too. And then in between are antinodes, where the salt, if it's there, will be like kind of hopped up into the air until it falls into one of these node regions. So you'll see that we're going to get another standing wave here, right there, and again it has a distinctive pattern. And again you can see the nodes here, and the antinodes are these whole black regions. Yeah, so that's standing waves again. And the important thing to remember is that you can get standing waves at specific resonance frequencies, and that's when the wave that you send in constructively interferes with the reflection. That means that energy tends to accumulate in the waves. It gets larger and larger and larger instead of being transferred. And you can think about that as the fixed end as a node, so energy isn't transferred. And then they get really large amplitude.